Hello, students. Mr. Soto back again. This time we're going to solve quadratic systems. It's a continuation. Okay, so let's continue with this. You'll probably end up getting a quiz sometime this week, Wednesday or Thursday. But first, let's continue with this review or this part of the lesson. So let's talk about some of the things which you should already know from solving quadratic systems. This is from the notes that I'm going to be publishing for you in Google Classroom. Before you solve systems of linear equations by graphing, substitution, elimination, we can use the same techniques to solve systems that include one or more equations of conics. These systems are called quadratic systems, because now the highest exponent is going to be 2, and we know that a quadratic equation has a highest exponent of 2. If the graphs of the equation in a systems are a line and a conic section, the graph can intersect in 0 solutions or 0 places. For example, this one right here, 0. So this one is the one right here with no solution. Okay. Then we have one solution, okay, which is this one. And here's an example of one solution. And lastly, we have 2 solutions, or it crosses at 2 points, which is something like this. These are not the only scenarios, but these are some examples. So you should be familiar that you can have no solution, one solution because it crosses once, or it can hit twice. So let's look at example number 1. Solve a linear quadratic system by substitution, okay? Which means that one of these has either x equals or y equals, or you can make it y equals or x equals. So what we're going to do is take the second equation. We're going to call this equation 1. We're going to call this equation 2, and we're going to substitute this y here. So we're going to have x squared plus y, but I'm not going to use that y. I'm going to use this in parentheses minus 3x plus 10, and I'm going to square that, is equal to 10. Okay? Which means that I've got a process to do right here by squaring this, combine my x's, and then solve it. So when you do this, remember FOIL, you do x squared, and then you do plus negative 3x plus 10 times negative 3x plus 10. And I'm going to bring the 10 to this side, minus 10, and make it equal to 0. Because I want everything equal to 0 because I have x squared, and I want a quadratic equation so that I can solve for x. So I'm going to subtract 10 to both sides, and I get 0 here. So here, when I do FOIL, I get x squared minus 9x squared minus 30x plus 100 minus 10 is equal to 0. All right? Then I'm going to combine my like terms. This is going to give me minus 8x squared minus 60x plus 90 equal to 0. Okay? So the first thing I'm going to do then is, now, is 90 divisible by 8? No, but I know it's divisible by 2, right? So I'm going to divide by, let me first check to see. I don't think 90 is divisible by 90 divided by 8. It's not, but it is divisible. Is it divisible by 4? 90 divided by 4, it doesn't. So it is divisible by 2. So I'm going to divide by, or factor out a negative 2. because I want a positive there. So I get 4x squared, right? And this is going to give me plus 30x. And this is going to give me minus 45 is equal to 0, right? So then now I have to do this process. When I divide everything by -2, the whole thing, that -2 disappears, and I have 4x squared plus 30x minus 45 is equal to 0. Now here, I can do the quadratic equation, and I can solve for x. So that's probably the easiest way because I don't want to multiply 4 times -45. So I'm going to have 4. So I'm going to have, remember, a is equal to 4, b is equal to 30, and c is equal to -45. So x equals opposite of b minus 30 plus or minus square root of b squared, which is 30 squared minus 4 times minus 45 divided by 2 times 4. So that gives me minus 30 plus or minus the square root of 900. And this is going to be plus because that's negative times a negative. So that's 16 times 45. 16 times 45 equals 720. And that's over 8. So x is equal to -30 plus or minus the square root, 720 plus 900, and then I'm going to take the square root of that. It's not going to give me a whole number. It's going to give me 1620 divided by 8, which gives me minus 30 plus or minus 40.25. 40.25 divided by 8. So my answers become x equals minus 30 plus 40.25 divided by 8. X equals minus 30 minus 40.25 divided by 8. This gives me what? Okay, so I have 30 minus plus 40.25 equals divided by 8 equals 1.28. And this one gives me 30 minus 40.25 equals divided by 8 equals negative 8.78. All right. Then I substitute those into this equation to get my final answers. So I'm going to do it right at the bottom here. I'm going to say y equals minus 3 times 1.28 plus 10. So that gives me, make that 3, make it negative, times 1.28, sorry, 3 negative times 1.28 equals plus 10 equals 21.52. And this y is going to give me negative 3 times negative 8.78 plus 10. So that's going to give me 3, make it negative, times 8.78, make that negative, equals plus 10 equals 36.34. All right? So this y applies to this one, and this y applies to that. My answers are going to be 1.28, comma, 21.52, and negative 8.78, comma, 36.34. Okay? And there is my solution for example number 1. Okay? So you should be able to follow that along. Okay, let's go to example number 2. Okay, and before we look at example number 2, okay, let's look at this situation over here. Okay, what that is we're going to talk about quadratic systems. Okay, it says two distinct, okay, conic sections can have from 0 to 4 points of intersection. Several possible scenarios are shown, and there's the 4 possibilities. So you can have no solution up to 4, and here are some examples. Okay, in the next example that we're going to do, we're going to use elimination process. Okay, so the elimination process means that all I'm going to do is I'm either going to add or subtract the systems to eliminate one of the variables and then solve for the other. Well, these are the best thing right here because these have the same numbers coefficient but opposite signs. So I'm just going to add those. So when I add those, these disappear, and I have 10x squared. And this looks like negative 106. Oops, it's not negative 106 because that has a negative 16. There's no x, so that is not that. Sorry about that. Let's change that. Okay, that's just negative 90x, and then plus 216 minus 16 is just plus 200, right? And that is equal to 0 because that 16 applies to this, not to that. Here I could divide by 10, the whole thing. So then I'm going to have x squared minus 9x, and that's just 20. Plus 20 is equal to 0. Now I need two numbers to multiply to 20 and add up to negative 9. Oh, that's easy. So then that's just FOIL over here. Or then I have minus 5 and minus 4. That gives me 20. And when I add them, so this gives me x equals to 5, x is equal to 4. Okay, and then I have those for x. Now I can just substitute that into any of the two equations. I'm going to use the second one. So I'm going to do 5 squared minus y squared minus 16 is equal to 0. This is 25. So then I got minus y squared, and 25 minus 16, that is positive 9, is equal to 0, right? Now I want to make that positive, so I'm just going to divide the whole thing by negative 1, and I get y squared minus 9 is equal to 0. Well, I know this is y plus 3, and this is y minus 3 is equal to 0. So this gives me y is equal to negative 3, and y is equal to 3. So, and that's when I get for this one. I haven't done this one yet. That's only for x. So I have two answers when x is 5. So my first set of solutions is 5 comma negative 3 and 5 comma positive 3. Now I've got to do the opposite with this one. So I'm going to have 4 squared minus y squared minus 16 is equal to 0, right? Well, that's 16. 16 minus 16 is 0, minus y squared is equal to 0. That's just y is equal to 0. So for the 4, I have 4 comma 0, and it's not plus or minus because 0 is not plus or minus. So we have 3 solutions for this scenario, okay? And there you have it, okay? So we're not going to do this real life example number 3, okay? But you are welcome to do it on your own if you prefer, if you like. If you don't, that's okay. I'm going to assign you some other things to do for homework. Take care. Keep up the good work. I'm proud of you. Hope to see you soon. Till the next time, Mr. Soto.